Hello, good morning. I'm discussing bond-lande equation. First of all, theoretical calculation of lattice energy. The amount of energy released when 1 mole of the ionic compound is formed from cation and anion in gaseous state is called lattice energy. It is also defined as the amount of energy required to break 1 mole of ionic compounds into cations and anions in gaseous state. For example, sodium and halide sodium and halides, sodium cation and halide anion reacted uh, by supplying the energy to form sodium and sodium halide ionic compound. Just opposite, the sodium halide is supplied the energy. It also produces sodium cation and halide anion. Okay, bond-lande equation. The bond-lande equation is means calculating the lattice energy of a crystalline ionic compound theoretically. In this method, the ions are treated as a point charge. According to Coulomb's law, the force of attraction between the oppositely charged ion is given by F equal to Q1 Q2 over R squared, where Q1 charge an ion, let cation, Q2 charge an ion, let anion, or distance between cation and anion. Now, if one of the ion is moved under the influence of electrostatic attraction by a distance of dr, the work done in this process is given by work done equal to F dr Q1 Q2 over R squared dr. Integrating above expression from infinity to R, the total work done infinity to R Q1 Q2 R squared dr equal to infinity to R Q1 Q2 R minus 2 dr, and solving Q1 Q2 over minus 2 plus 1 R minus 2 plus 1 infinity to R minus Q1 Q2 over R infinity to R, again solving minus Q1 Q2 over R minus Q1 Q2. So dividing by infinity equal to 0. Total work done equal to minus Q1 Q2 over R. Total work done is called electrostatic energy or attractive energy. Since Q1 equal to Z plus E, Q2 equal to minus Z minus E, so the electrostatic Coulombic energy between two ions of opposite charge is given as EA, means attractive energy, equal to minus Z plus Z minus E squared over R, equation first. EA means attractive energy. where Z plus and Z minus are the charges on positive and negative ions respectively. E, electronic charge or interionic distance. Total attractive energy depends on the number of ions and the geometry of ionic compounds. Hence, for 1 mole of ionic compounds, the equation first should be multiplied by two constants, one which represent the number of ions in 1 mole of ionic compound, that is Avogadro's number, and not ion, another which represent the geometry of ionic compound. Now equation 1 can be written as so that attractive force E minus R naught A Z plus Z minus square or equation 2 where R naught is the Avogadro's constant 6.023 10 to the power 23, a Madelung constant. Value of A depends on the crystal geometry. The value of Madelung constant depends on the geometry of ionic compound. All ionic compounds which belong to a particular crystal structure have a particular A value, that is Madelung constant value. The value of Madelung constant A for different crystal structures have been calculated theoretically. When positively charged ions come together to form a crystal lattice, it is not only the attractive force that exists, but there is also repulsive force among them. Such repulsive force arises from interelectronic and internuclear repulsion of two ions. Such a repulsion is expected to increase with decreasing interionic distance R. According to lande, and the repulsive force ER is given by ER equal to B over Rn, where B equal to a constant called Born coefficient, which depends on the coordination number, N equal to a constant called Born exponent, typically between 5 and 12 of 1 tends to 9 for alkali halides. The total energy of the crystal lattice is the sum of the attractive force and repulsive force equal to A plus ER. The total energy is called lattice energy that holds the ions in crystal, hence lattice energy U, attractive force EA, repulsive force ER. So U equal to minus N naught AZ plus Z minus E square over R plus B over Rn, equation third. It is possible to evaluate the coefficient B at a distance where attractive and repulsive force of a positively charged ions are exactly balanced. This distance is called equilibrium distance or R naught. Let at equilibrium distance R equal to R naught, then du over dr equal to 0. Now differentiating equation third with respect to R naught, du over dr naught equal to minus n naught az plus z minus e square d over dr naught, r naught minus 1 plus b d over dr naught, r naught minus n equal to 0. This is the formula of the derivation d over dx xn, n xn minus 1. du over dr naught equal to n naught az plus z minus e square over r naught square minus bn over r naught n plus 1 equal to 0. bn over r naught n plus 1 equal to n naught az plus z minus e square over r naught square. Solving b equal to n naught az plus z minus e square over n r naught square multiplied by r naught n plus 1. Substituting the value of b in equation third, u equal to minus n naught az plus z minus square over r naught plus n naught az plus z minus square over n r naught square multiply r naught n plus 1 over r naught n, substituting value of b in equation third. And solving u equal to minus n naught az plus z minus square over r naught plus n naught az plus z minus square nr naught square minus n minus 1 plus n cancel, and 1 is subtracted from, so n r naught 1, that is n r naught. So u equal to minus n naught az plus z minus square r naught plus n naught az plus z minus square n r naught. U equal to minus n naught az plus z minus square over r naught 1 minus okay, u equal to minus n naught az plus z minus square over r naught 1 minus 1 over n. Equation 4. Equation 4 is called Bone-Landy equation. In SI unit, this equation can be written as u equal to minus n naught az plus z minus square 4 pi epsilon r naught 1 minus 1 over n. Equation 5. Okay, where epsilon naught is permittivity of vacuum, and equation 4, we have written equation 4 here. Sorry, equation 4. Okay, equation 4 is called Bone-Landy equation, which is used to calculate the lattice energy of ionic compounds theoretically. Consequence of Bone-Landy equation, Madelung constant. Lattice energy of ionic compounds is directly proportional to the value of A. It means that lattice energy increases if the value of A increases. Charge and ion, lattice energy of ionic compounds increases, the product of charge ion Z plus Z minus increases. That is lattice energy proportional Z plus Z minus. Interionic distance R naught, lattice energy of ionic compounds decreases if the size of the ions increase. That is lattice energy inversely proportional 1 over Rn. Okay, it's all about Bone-Landy equation. Thanks for watching, and request all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you.